now, and so on. So today is the introductory lecture, and we will talk about, in general, what is petroleum engineering, the branches of petroleum engineering, and the phases and of petroleum engineering, and so on. So first, let's discuss what is petroleum engineering itself. Well, petroleum engineering is an engineering discipline, okay, concerned with activities related to the production of hydrocarbons, which can be either crude oil or natural gas. Basically, petroleum engineering deals with two main products. Okay, one of them is oil, other one is the gas. We want to produce both of them, and both of them has changed the world. For example, crude oil, it is used when we distillate it, when we convert into the fractions. Some of it, part of it is used in the cars you use as a jet fuel. It has many byproducts, as you know. It's used in the cosmetics and makeup stuff. It is used, the bitumen is used in the, you can say that in the road construction. So there are a lot of benefits of this crude oil that the world is taking advantage of at the moment. This natural gas again is a very, it's a byproduct, you can say. Also, it's very important. It has number of functions. First, it can be used to generate the electricity, this natural gas. It can be used to, let's say, fuel the car also. It can be used as a car fuel. Also, this is used for the heating purpose in Europe mostly when in winter. Or here also we use it as the heating purpose during the winter. So petroleum engineering basically deals with the upstream sector. As you know, we have three different sectors: upstream, midstream, and downstream factor. Here we are dealing with the upstream factor of oil and gas activity. So basically our objective as a petroleum engineer is to produce oil and gas safely, economically, and in the minimum time. That's the job of the petroleum engineer. That's why it's very clearly mentioned here that we are involved in the activities related to the production of hydrocarbons, and those hydrocarbons are oil and gas. Okay, now we as a petroleum engineer, we are involved into almost all the stages. Okay, and when I say all the stages, these stages means that we are involved starting from, you can say, the exploration phase till we end up the oil well, or when the oil well production has declined and so on. And as an engineer, what is our main target? What we do? We maximize oil production. We have to produce maximum. Okay, we have to produce maximum, and the cost has to be minimum. That's the main idea behind it. So what we want to do is we want to produce high, cost should be low, and the other concern is the environment. We have to keep our environment clean and safe. That's the main job of us also at the same time, and also at the same time safe. Okay, environmental problem should be less. We should take care of the safety. At the same time, we produce maximum hydrocarbons, and the cost should be the minimum. That's the whole idea of a petroleum engineer. Now, this petroleum engineer domain is divided mainly into four main parts. One of them, you can say, the reservoir engineers. Second one is the drilling engineers. Third one is the production engineers, and fourth one is the artificial engineers. So I will first start with the drilling engineers, and then I will move to the production, reservoir, and artificial, and so on. So let me first show you some videos of these four, and then we talk about every one of it in much details and so on. So let me stop this here and allow to. Let's look at this part. area, you are out of cities and somewhere in the middle of nowhere actually. And our job as a product petroleum engineer, one of our job is to drill the oil wells. So drilling engineering is one of the major domain that petroleum engineers they cover. And you basically work here for 12 hours, sometimes 6 a.m. in morning till 6 p.m. And I must tell you, the food is very nice in those places. It's like a 5-star menu. So after you graduate, it's good to go there for a few years, and you will enjoy it because you will see deserts, you will see a lot of places that you will never see in your life, because mostly drilling locations are really remote areas. So now you can see that this is a big machinery, and there are a lot of people working here. And there are a lot of mechanical engineers, petroleum engineers, drilling engineers. There are civil engineers also at this site, and there are lots of technicians. So there are a lot of people working at the same point there, and their all main objective is to reach to the target zone and to the reservoir. This is one of the job that as a petroleum engineer you have to do. Now I will move from drilling engineering to the production engineering. After you complete the drilling, we install something like this. It is called a Christmas tree. And here you can see.
Engineers, here you are. This is what we call.
So this is called the Christmas tree. After you complete your well here, your drilling is completed here. They remove the drilling rig and they put this Christmas tree there. And this Christmas tree then later on has lots of valves here. You see there are a lot of flow meters, flow devices, temperature sensors, pressure sensors, sand detectors, and so on. And the oil or gas from here is coming and moving ahead to the next direction. Yes, Mr. Aros.
Sir, what is the purpose of this Christmas tree? What does it do?
Its purpose is to control the oil flow. For example, if there is no control, then oil will, under high pressure go out, and you cannot direct it anywhere. So what we have is like a tap water, exactly like tap water in our homes, like in kitchens and toilets. The tap water we have. So the more you open, the more oil will come. The less you open, so it's like a tap of the oil well. If it's not there, then there will be no control over the flow. It will be uncontrollable.
Makes sense. Thank you.
Sir, I got a question.
Yes, sure.
In the reservoir, we have we have 3-stage gas, oil, and the water.
Yep.
Do we have to any pump to pump the oil up to the ground, or it's the pressure, it's the gas that makes the pressure and put the oil up to the ground?
Well, there are a number of sources of pressure, and we will discuss them later on. We call them the drive mechanism. There are a lot of drive mechanisms there. So sometimes the water is the source of pressure, and which is the best source of pressure. Sometimes the gas is the source of pressure. Sometimes, the rocks are pressurizing the oil. So there are a number of mechanisms that are involved in this pressure as well. But this is as a general, I tell you that as we go down, the pressure is increasing. As we go down, right now we are at the surface of Earth. For example, you know, I give you a very funny example. For example, there is a thin guy, and you know, 3-4 people are fighting with him, and 3-4 of them are on over him. So you see that the thin guy will be under very high pressure. You know, all the other 4 people are putting his weight on him, so he will be under high pressure. So exactly the same scenario. So now we are 2,000 meters below, and there is a lot of rock above it. So these rocks are causing lots of weight on that oil, which is causing the pressure. You got the point?
Thank you so much.
Yeah, so there are
Yeah, I
many
got
other
it.
sources. We will talk about them in details. Maybe partially we'll talk about it here, but if there's a reservoir engineering course ahead, I'm not sure. So we will talk in reservoir engineering that one. Because that
And
is
also,
particular. Yes.
in this video, sorry for interrupting. In the Christmas tree, I couldn't recognize any pump, any device that could just bring the oil and put pressure on the oil so that it's gonna
No,
come
no.
to the ground.
It's just a valve. You see, there are
Right?
valves.
It's a valve. There is no pump.
There's no pump because reservoir itself has a lot of pressure. Okay. So if you
Exactly.
open it, the water will come. Sorry,
Exactly.
not the
Thank you.
water, not the water. Sorry, oil will come or gas will come, not the water.
Thank you so much.
Okay. So these valves, if you open them, oil will come. Okay, and how the pressure is working, as I said, as we go down, there's a pressure in the oil. And exactly it works like the same in the kitchen or toilets in our home where water has a pressure. You open them, water is coming out. Why? Because there's a pressure in the tank. Okay. It could be because of the gravity. If you remember the hydrostatic pressure, because of the gravity, hydrostatic pressure, there's, as I said, the water is causing the pressure. There's a gas causing the pressure. There's a gas mixed in the oil, which is causing a swelling effect of the gas, which is also causing the pressure. So there are a number of mechanisms. What do I mean by the pressure? It's energy. It's a force per unit area. So these all mechanisms are causing force to this oil to come out of the hole. Exactly like volcanoes. If you remember the volcanoes erupt, they come out because there's a lot of pressure, heat, temperature, so they erupt outside. Any question more? Anyone? Okay. If you don't put this device, you know, there will be flow of oil and you cannot control it. You cannot direct it anywhere. So we have to put this device and put it under the pipe. Now safely our oil is coming out of and it is going, and we cannot even see it here at this point unless it reaches to the other parts, call them the separator. Yes, please.
Sir, sorry. In some other fields, I have seen that they use jack pump oil. May I know the difference between jack pump oil and Christmas tree?
Sometime what happens after some years of production, right now this is an initial stage, okay, the pressure declines, okay.
Yeah.
At some point, for example, you are starting production, let's say in 2000. So from 2000, pressure is very fine, you are getting a very nice production and so on. But after from 2000 to 2010, the pressure starts to decline. Remember, the reservoir is alive, it's very dynamic, and the situation of the reservoir is changing day by day. So the pressure starts to decline, and at some point, it happens that the oil is not coming up using just this Christmas tree.
So that means it is going to be used for low level of oil, right?
This is used when there's a very high pressure and very, very high level of oil.
Okay, thank you.
Okay. But after some time, the pressure will, we take out the production. Now the less oil is remaining in the reservoir and pressure has declined. So we have no choice. What we do, we put the pump. Now, which kind of pump? Exactly the water pump at your home that you use for lifting up the water from one point to another point. Okay, so same kind of water pump then we use. We put it instead of this Christmas tree, and which is just removing the oil, pumping the oil from the well to the surface. But at certain point, even that fails. Okay, so this is, we call it the primary mechanism, secondary mechanism, and then we have the enhanced oil recovery mechanism. So this one actually we are talking about the primary recovery here. This is under primary recovery. Then the jet pump you are talking about is the secondary recovery. And if you see in the previous video, in the drilling video, there was one jet pump on site. If you notice it or not, or once I upload the videos, you can figure it out. There is one pump in another well site on. So after that jet pump thing fails, then we go for the enhanced oil recovery. This is the tertiary recovery, we call it. And I will show you a video after this this one about the enhanced oil recoveries and also. So if you notice from here, there's a pipeline going on from, look at this one, from here, this one is going from here. So remember, in every field, there is not only one well, there are many wells, at least 5, 6, 8, 10, sometimes 100, sometimes 300, sometimes 400. So there are a lot of wells. So what is the job of production engineer? Okay, he records the flow rate, pressure, temperature, everything every day, in morning, in evening. This is the job of the production engineer at site. Okay, so if, say, for example, you are hired there, so what you need to do, you have to make sure that the production is continuous 24 hours. So you have to sit in front of the computer. Okay, there's a reading coming, how much oil is we are producing, how much gas is there, and if there's any problem coming up, how much water production. So you record the production history. We call it a production history. How much oil is produced, how much gas is produced, how much water is produced, is there any problem, is there sand production. So we take all this data and we send it to head office. This is the job of the production engineer at site. Okay, so mostly you will be just sitting in front of the computer, taking all the data. And if there's any problem, write it to the head office. Then head office will handle it further with other engineers. This is job of the production engineers. And so these devices are operated by two ways. Once by hands manually, and then by using the actuators by hydraulically, they can operate from their main office. This device.
This is the rotary valve. The rotary. Flow line.
So for example, there are 4 wells or 6 wells, all the production is gathering at one point and then they are storing it someplace and then moving to the refinery. That's the job of the production engineer. Earlier, as I showed you, the drilling rig, their job was to drill the well, and after drilling this production comes. Now I will show you further what are the further jobs. This is the formation.
What is an oil reservoir?
So now the third domain, one of them we say is the drilling engineering. Then we said it's a production engineer who manages that production and Christmas trees and log and record the production data every day and night, and then they send it to head office. Third one is the reservoir manager, the reservoir engineer. Though their job is to manage this reservoir. So let's look at it. What is it?
Oil reservoirs are vast layers of porous rock containing natural gas, oil and water, typically buried a mile or more underground. The largest ones may be spread over many tens of miles and contain billions of barrels of oil. The porous rock has enough permeability.
So I remember one of my students actually asked me in the previous semester that is reservoirs like a swimming pool? This was his question. So actually, no, it's not like a swimming pool. It's like it's the rock, and rock has small spaces. As you see, this brown represents the small tiny spaces. These tiny spaces has the oil. It's not like swimming pool that you see in Grand Millennium. It's like a rock which has a small crude oil here in the small pore space. We call it a reservoir rock pores. Okay.
To allow oil and water to flow through it. But in order for a reservoir to form, The porous rock needs to be capped by a layer of impermeable rock. Then, over millions of years, the rock tends to deform to create a trap. That way, conventional oil and gas, which are less dense than water, are able to naturally percolate upwards through the porous rock until they are blocked by the cap rock. And a reservoir with production potential is formed. But recovering that potential oil is not as straightforward as you might think. Porous rock needs to be capped in parts which are less.
Okay. Now, in the next lecture, we will talk about the cap rock, source rock, what are the types of traps, what is anticline, syncline, and migration, and so on. So this is the geological part of the rock that we will talk in later on. But today we are just introducing what is the types of engineering disciplines that a petroleum engineering has to continue. So as we discussed before, this rock, you cannot touch it physically. You cannot reach the physically. Drilling engineering is a kind of a physical job. When you go on the rig side, you drill the well, and that's it, done. Production, as I showed you, there are Christmas trees installed. One of your job is to install that Christmas tree and then to manage and to monitor the production data that you are doing there. Third job is the reservoir one. As I said before, that you cannot touch the reservoir. So all is the creativity, and there's a lot of mathematics behind it. So reservoir engineering is mostly based on a lot of empirical, okay, and mathematical equations, and lots of laboratory data, and lots of imagination. Okay, a lot of imagination, a lot of mathematics, a lot of empirical data, experimental data. So it's all about imagination. So while the rest two of them are mostly the physical kind of things, and you can really do it. There is a mathematics involved in production engineering. There is a lot of things involved, but you know, at the other side, there are something physical that you can see, the plumbing system. Now we have the fourth domain that nowadays we are working on. We call it an enhanced oil recovery, which comes after those jet pumps. And I will show you a video about it. And then I move to my lecture, back to my lecture. Okay, here you can see, this is, let me first explain what's going on. Here we have 5 wells. As one of you said, we have the jet pump here. See, we have a jet pump here. This is the jet pump here. We don't have a Christmas tree, we have a jet pump here. So we are actually experiencing a 5 spot wells. We have 5 wells, one this one, this one, third is this one, fourth is this one, and the fifth is this one. Now in this case, what we are doing, there is no enough pressure. This oil, which is this black you see, is a crude oil. This oil cannot come to the surface. Okay, this oil has a problem, cannot come to the surface. These jet pumps are also not working enough. There's no enough pressure. So what we need to do, what we are doing here, now we are injecting the water back in the reservoir. Reverse process. We are not producing from it, but we are injecting the water back. So once we are injecting the water is then pushing this oil towards these wells, and this well, through the pumps, we take it out again. So let's look at the phenomena, how this is happening. So this is the natural water. These are the water storages we have here. And from this water is pumped down. We are sending this water down towards the oil. Now, what this water is doing, it is pushing this oil towards the wells, oil. Now oil is coming up. So this happens after sometime, even the well is discovered, it needs this enhanced oil recovery. But sometimes after 12, 20 years, 25 years, this EOR is needed. So now you see we have lots of, after we injected the water, we push the oil, and now we are getting the oil by the pressure. It's a very simple description, but it's not as simple as you see it. Yes.
Excuse me. Is that possible that we do not have natural water in the area?
Yes. Like every phase is different, every reservoir is different.
Well,
okay.
So in this case, that they need to supply water from the other places, or maybe they use another method to.
Yes.
drag down the water.
And yes, there are so many methods, enhanced oil recovery methods. There are chemical methods, gas injection methods, thermal injection methods, so many methods. It's a separate engineering behind it. And you may be expert in one, but you cannot expert of all. Okay.
Thank you so much.
Yeah. Any more questions? So,
Sir, so
yeah.
yes, I have a question. So if there's enough pressure, we use Christmas tree, and if there's not enough pressure, we use that jet pump, or what is
Yes.
it called?
Yes.
Pump?
There are many kinds of pumps, but one of them is the jet pump. Yes.
So that's correct, right?
Yeah. It works like you have a straw in the cola and you drink from it. So it has the same mechanism of sucking. Sometimes we call it a sucker rod pump. Sometimes we call it jet pump. Sometimes we have other methods also. Okay. There are 5-6 different methods.
Sir, sorry, I have another question.
Yes.
Let's say if the pressure of the reservoir is equal to the pressure of the air surface,
Yes.
then beside the jack pump,
Yes.
how the engineers handle the situation?
Yeah. Then they have to inject this water, as you see, one of the reason, or they can inject the gas also, if there's a gas available nearby, and they can source it. Sometimes they take the nitrogen from the air. Sometimes they take the CO2 and they inject it back in the reservoir. Okay, which is causing the pressure or a piston-like movement for oil to flow out to the surface. Okay, or sometimes there are not the pressure issues, but other issues like wettability issues. There are a lot of chemical methods. There are a lot of thermal methods. For example, you have the oil. For example, you are in Alaska, or some parts of Russia or China where temperature is -40, and you are producing heavy oil like Canada. Okay, as I said, oil has different types. Some of them are light oil, easy to flow. Some of them are heavy, which is hard to flow. So in -40 degree, when this heavy oil tries, even it has pressure, it tries to come out, it freezes. Okay, because of the cold weather, it cannot move because it freezes, because it's heavy. So in that case, we have to use the in-situ combustion. So there are a lot of situations. Okay, this is just a very, very simplest form of depiction.
So it's possible to make pressure recovery?
Pressure cannot be created naturally. We have to induce it by injecting water or gas.
It cannot be so.
Yeah, cannot be naturally, cannot be artificially. We could do. We call it enhanced oil recovery. We enhance the oil recovery by inducing the pressure. Okay. And how we simulate these situations? Actually, as I told you, we cannot touch the reservoir. All we can do is using the softwares and simulations. So we have a lot of softwares for it. And I would like to tell you that yesterday we got a simulation software for this by a Kappa Engineering, and it will be in your labs very soon. This semester I'm working on your softwares also, so you may access them for your projects. All kind of software of petroleum engineering, they will be in your lab by the end of next 2 months. But for first one we got it by now, and we are in process of licensing. Inshallah, it will be done. I just have to sign one paper and send them today. So hopefully you will get it by in few weeks. It will be in your hands to simulate these situations. Yes, more questions?
Will we get the opportunity to try those softwares and
Oh yes, I
go
will
to
teach
the
you. Oh yes, I will teach you.
So it means that we are going to the actual labs on campus?
It's up to you. I mean, I don't know how this energy department has worked before, but I will train you before you go.
Thank you so much.
That's my plan, but I don't know how I will achieve it. But let's see. But for now, first point was to get them, to reach them to the energy engineering department. So I'm successful in that, and I will get you all of them.
Sir,
Yes.
will this water injection process have any negative effects on, for example,
Negative effect? Yes, there is a very, very good question. Yes, there could be a lot of negative effects. First of all, what if this water is not compatible with the rock? Okay, if it is not compatible with the rock, it will create a formation damage. Okay, so what we have to do first, try this water with the rock in the laboratory to see that if this water is compatible with this rock or not, because rock has minerals. Okay, and when this water is composed of H2O, hydrogen and oxygen. So when this H2O goes down, how this will react with the minerals? If it is working, impacting negatively, it can do the formation damage. Okay, this is the first question. Now, the second question comes in that at what pressure you are injecting. What if you injecting with a very high pressure, it fractures and destroys everything inside. So you have to know at what pressure you are injecting. Third one is the amount, like how much water exactly you are putting so that it can affect this oil to come out. So there are a lot of parameters and factors that affect this water production. So again, you have to do a complete simulation and engineering studies and projects behind it to make it a successful. Usually we look for injection pressure, we look for injection rates, we look for injection temperature, we look for, sometimes this happens, the reservoir temperature is 100 degrees centigrade. And at that point, as you know, that oil or water becomes steam. So will this steam will work or not? So these things matter. The other thing which is important is the distance of these two wells. Here you see, this is the production well and this is the injection well. And how much is the distance between them? How many kilometers or meters? And which one is the best and why? In that case, it needs an advanced study, and maybe in your master's, you will learn that. But in bachelor's, we can try some of them and find out which one is the optimum distance between both of them. So again, it's an engineering, let's see what courses you have next for petroleum engineering. So we can talk about it more. Or if not, then I will give you the resources, right resources you can study before you at the time of your graduation. Yes, more questions? Okay, so we continue here. Please, I got some very nice questions, so I expect more in the comment. Okay, so now I will stop it here, this one, and go back to my slide, which I was talking. So now you got the idea what are the reservoir engineers, drilling engineers, production engineers, and artificial lift engineers. You got some idea? Okay, thank you. Now we go ahead. Where these petroleum engineers work? Well, they can work in oil government sector. They can work in the oil companies. They can work in the service companies. They can work as a teachers, and they can work in a supporting companies who provide like cementing, casing jobs, and so many other jobs, fracking jobs, and so on. So location, of course, you can work in your office, okay, as a reservoir engineer. Of course, you can work in the fields nearby. Let's say you have in Suleimani or here, or you can go offshore oil rigs or offshore production platforms. So these are your locations. You can work on office, you can work on the land, you can go to the offshore rigs, and you can work as the offshore production platforms and so forth. So these are the locations, and you can definitely work for the ministry because ministry has to keep in track on everything what is going on in the region. Though they keep everything very, very confidential. Okay, why? Because, okay, leave this topic. Oil company, service companies, supporting companies, academics, and so on, you can work on them. Or location-wise, office, land rigs, offshore rigs. Offshore means, talking about the sea, the water situation, the water there. Okay. Now, the second thing come, what is the petroleum? Petroleum itself means a rock oil. It is taken from the word petra, which means a rock. And it's a Latin word. Oleum means oil. So the petroleum word means a rock oil. This is the normal definition we tell to the students. Even when I was student, I got to know this definition from the beginning. Well, at the historical perspective, as I told you before, bitumen is used in the road constructions. There are a lot of benefits and cosmetics it is used, which was used for building as a fuel for lamps. So kerosene, as you know, is used for the heating and lighting purpose in old times. So there's a lot of historical perspective for this. The first well was in 1848. The first well was drilled in Baku, Azerbaijan, which is a very nice tourist place nowadays. And so there are a lot of previous history behind these oil wells. And just to remember that the first well was 1848. And 1859, the Colonel Drake successfully drilled the well at the depth of 69 feet in Pennsylvania. So these two wells are quite famous when we talk about history of oil wells and so on. Now, here this chart is very interesting and is a must for everyone to know. Okay, and you see a lot of things here, life cycle of an oil field. Well, as you know, when we look at the graphs, we look at the x-axis first, and we look at the y-axis first. Now, the first, this life of an oil field is divided into the three main phases. This is the first phase, this is the second phase, and this is the third phase. Okay, in the first phase is the development phase. In the development phase means you are exploring and we are drilling. So it means that we are spending a lot of money behind it in the production rate, in the development phase here in the first region. So we are spending a lot of money. But in this plateau phase, where we have the primary recovery and secondary recovery, there are two words. We talk based on the pressures. Primary recovery means the field has enough pressure so that we can produce. Secondary recovery means it needs some pumps and enhanced oil recovery methods and so on. In secondary recovery. So in the first phase, actually we are developing, we are drilling, we are exploring. Second phase, we are producing. This is the phase where we make a lot of money and is quite stable. You see the line is quite stable. So this second phase, plateau phase, is the one where the oil companies, they make a lot of money. For example, now I give you a simple example. How much is the money? Let's say there is a Sarkala in here in Kurdistan region. I went there and their average production is around 30,000 barrels per day. Okay, 30,000 barrels they are selling every day. So as per today's price, let's say $42. So just multiply with 30,000 barrels a day. So you will get the money they are making in a day. Okay, so that is the real money that they are making. That oil through the trucks they are sending to the other places, to the refineries. But anyway, they are sending 30,000 and their pressures are very nice, very high. Their pressure was, initial pressure was around 5,000 PSI. Their bottom hole pressure, running pressure was around 3,700 PSI. Very nice pressure. They could extend this 30,000 barrels to maybe 100,000 barrels. They can do it. They were drilling more wells. It's under the development stage right now. And another thing I would like to tell you, Kurdistan oil and gas is still in the development phase. We are not in the middle phase. So this is the only region in the world where oil and gas is not in this phase. For example, if you look at the situation in Emirates, most of their fields are now in the declining phase, not in the plateau phase or the development. But in Kurdistan, you are lucky that you are going to have oil for a long time, unless the renewables are going to replace it, which is probably going to happen in the next 5 years. Okay. Now, as I said,
yes. As high as the profit.
Profit, as I said, $40 for now. Okay. And if the field is producing 30,000 barrels, so multiply it by 40, so you get the money every day.
But what about the expense?
Expense for producing that oil, they have few engineers, they have done the drilling. Okay. They have done the exploration. So definitely they have some capital investment. Okay. This depends on, but as I tell you, in Iraq is the minimum. If you compare it with other places, is the minimum than other places. The real cost, but if the commissions and so on, so there are so many things in this thing. So in the oil field consists of 5 main sections: exploration, appraisal, development, production, and abandonment, as we talk about here. We explore, we develop, we have plateau phase, then we have the decline phase.
Doctor, I have a question.
Yes, please.
So you said some reservoirs can be as large as a city.
Yes.
So does the oil taking, does it cause like the ground instability?
No, it doesn't, unless you do the fracking. A lot of fracking.
What is that?
Fracking is the fracturing, is creating a blast inside, crack the formation.
Okay.
Which is going on in US right now. That's why the earthquakes there are a bit high.
Yeah.
Okay. On the other side, we have the Kirkuk reservoir here, and Kirkuk is the 3rd largest reservoir of the world. Kirkuk has a value. Kirkuk is the 3rd largest reservoir of the world. It has that much oil, but that's why it's disputed, and everyone wants to take it because it is huge, and it's very old. But still, you see, it's continues since 1940s and 50s, and still it continues. Okay. So in exploration phase, as you see that here we are just investing the money. And from the production, you reached the maximum profits now. So here we are making lot of money, revenue. We are talking about the revenue. You can say in millions of dollars. Okay, so here you see the money is increasing and then starts declining. Why is this starts declining? Because the pressure is declining. Okay, remember till today, no matter what technology we have, we are still unable to produce 100% of oil from any reservoir. We can maximum our production, maximum oil that we have produced is 70% from the reservoir. You can say that. We couldn't produce so far 100%. Still, there's a lot of oil which is remain behind in the reservoir, and we don't have technology to crack it out, to take it out. Okay, still. So in this, the first phase, this exploration phase, you are just investing in drilling, exploring, and so on. And then the money gains up, you started making money. And then it starts to decline because the pressure is declining. So what is our job as a petroleum engineer to sustain this middle part, the production part, to have the highest production, and we try to maintain it. Okay. Sometimes this is declining because the water production is increasing, which is the case for Ginel in Kyrgyzstan. Before when they came, they were producing a lot of oil. They had no water production. And then suddenly water production increases. Now they are facing a lot of problem of this water production. And they don't know what to do with it. And it needs a lot of studies. So what is the exploration phase? Well, it's about finding oil and gas, simple. And we do the seismic surveys. We will talk about it in much details. And we do the seismic surveys, we interpret those seismic data. Okay, we set the location for the wells, how many wells we are going to drill, exactly where we are going to drill, what are the properties of the rock, for example, what is porosity and permeability. We will talk about it in the coming time. We do lots of testing of those. We talk about the fluid analysis, what kind of fluid we have light oil, heavy oil. So this is all goes in exploration. We explore, we set the number of wells, we decide, and that's the exploration. Then in the appraisal situation, we drill more than for one well. We have, let's say, 2 or 3 wells, 2 wells, one more well, you can say. In that one, we just want to confirm the data that, okay, how much oil we have, okay, and how much this field is going to survive, how many years, next how many years. And based on that, we develop further, we invest more money. So now, in this appraisal stage, we drill 2 wells, we have all the data, we are sure that this oil, let's say it has 1 million barrels of oil, this is going to survive next 10 years, okay, let's invest some more money, we can drill 10 more wells, and we can, so it's all the planning and the execution of data. Because, the money when we talk about, it's not about $1 or $2, it's about millions of dollars. So you have to put in the drilling the wells and producing those wells. So based on the data of exploration, and we recalculate, reassess everything, we plan it well, and then we go for the development. So we put number of wells, we develop number of facilities, we spend a lot of money. We are sure that, okay, there is oil, we are going to remove, we are going to earn some money, and we will recover our investment out of it. So definitely then we go for number of wells, we drill, we develop lots of facilities, and definitely then we hire a lot of high level engineers who maintain those production levels there at this point. In the production phase, this is the best phase where the company makes a lot of money, and they regulate the production and injection in approved plants. They monitor all the record of reservoir. They try to maintain the reservoirs. They try to increase the life of the reservoir. They try to produce as much as possible. So that's the job at this point. At this point, they are easy. They are making money. Oil is coming out from the well. So overall situation is very fine, this one. So after this very lucky and fortunate and prolific section of phase that passed away, we make a lot of money, we produce a lot of oil, we sell a lot of oil. Then the time comes when it no longer serves our purpose. It could be many reasons, because the pressure has declined, maybe water production has raised, or maybe oil is finished. So 3 of the things. Then in the end, what we do, we just put the cement plugs and we just close everything. We remove our stuff, we pack our bags, we go to our home. That's what the majority of the company. But usually the life of the oil fields is more than 50 years. Okay, it's not like you start today and after 2 months, 2 years it's gone. No, I'm talking about the Middle Eastern oil and gas reservoirs. But if you look at the US reservoir, shale reservoir, it's a very different story. And their life maybe is 2 years maximum. 2 years, 3 years. That's why the cost of producing shale oil reservoirs is quite higher than this one. Well, now I will
Doctor, I
talk
have a
about,
question, please.
yes.
Yes, Doctor, is that pressure the only reason for abandoned phase, or there are many reasons?
There are 3-4 major reasons. First of all, oil is finished. There's no oil, so
Okay.
what you will do? You will abandon it, right?
Yes.
This is the first one. Second one, maybe there's no pressure and you cannot take the oil out to the surface. Okay, this is the second reason. There's no enough pressure and you cannot do anything with it. You tried whatever you could do, or it needs lots of investment and maybe return maybe not that good, so you close the well. Third one, maybe sometime you close the well when the water production becomes too high. Okay, for example, you are producing 10 barrels, out of 10 barrels, 8 barrels water is producing. So in order to manage that 8 barrels of water, you need to spend a lot of money, which is more than the cost of these of 2 barrels that you will produce. So let's say you produce 2 barrels, it will give you $80. So, and to settle those 8 barrels of water somewhere in a storage or somewhere, it costs you maybe $200. So sometimes water production stops you to continue with the well. These are the reasons. Mainly the
Okay, Doctor,
pressure.
thank you so much.
Mainly in the technical term, we call it the oil saturation. The oil saturation decline in the technical reservoir engineering term. So we call it oil saturation. But in the as a layman, as a normal general public, we say, okay, oil level decline. Okay. So now I will talk about. Okay. Is there any more questions from the appraisal, exploration, production, abandonment?
Well, there's one more question, please.
Yes, sir.
So in the oil fields, in the oil plants, we measure the rate of production based on a barrel or based on tons of oil?
No, rate of barrels. How many barrels we put, not in tons. But when we sell it, we talk in tons. Yes, you are right.
Yeah, exactly. Because the place I served in, we talked about tons. You know, all different kinds of components that we had. We just sell in tons.
Yes. But because all our calculations are based on barrels per day, barrels per minute. If you go into reservoir engineering, production engineering, all the calculations based on barrels per day, barrels per day. So, but when we sell it, definitely we talk about in tons.
Yeah, thanks so much.
Yeah, that's how. And you're right. You pointed out very right things here. So now I'm talking about the top 10 producers, oil producer in the world, and Iraq is the fifth one. Is the top producer. And if you had more stability, better engineering practices, more good engineers, probably you can jump into the second. Okay, there's a lot of oil and gas here, but there's no technology. There are no people who can extract and sell this oil. And because of the government and politics pressures, maybe there's a limitation to produce that much oil. But anyway, as a top 10 oil field production, Venezuela is top. Saudi Arabia, they have a lot of oil. Canada, they have a lot of oil. Iran, Iraq, they have a lot of oil. Kuwait, they have a lot of oil. Russia, UAE, Libya, Nigeria. There's no US? Okay. US is at the top right now. They are almost producing 11 million barrels a day. It's higher than the Saudi Arabia. So right now, US is the top. Second one is the Saudi Arabia as per today. And you can follow it in, I can share with you the latest data for oil and gas production. Also, you can check on oilprice.com, the data of production. So Venezuela, Saudi Arabia, Canada, Iran, Iraq, Kuwait, Russia, UAE, Libya, Nigeria, plus definitely champion of all of them is US, which is producing a lot and spending a lot of money on research as well at the same time. Okay, now we talk about the crude oil. Okay, so far any question, and how much time is left? Any question? No question. Okay. So the oil that we produce from the underground reservoirs that we talked about, we call it a crude oil. Okay. It's a mixture of different chemicals. We call it hydrocarbons. Okay. Now these hydrocarbons, crude oil is a toxic. Remember, it's a toxic. It's natural. It's toxic and it's a flammable. It can catch fire. Okay. And it's a mixture of different hydrocarbon of different molecular weights, organic compounds in geological formation. So this petroleum crude oil is we divided into the 4 main chemical composition. I'm talking about now its chemical composition. We divide into the alkanes, alkenes, and then we have paraffins and naphthalene. These are the four ones. Just difference in there is the composition. Okay, for example, it has in the structure it has 4 hydrogen bonds, atom bonds here, but in the other one, okay, in alkane you see here we have the 4 chains, but you see here in alkenes there are the 4 hydrogen bonds, but they are connected in a different way here in this one and in this one. So there's a difference in the chemical composition, but hydrocarbon generally we have alkenes, alkenes, paraffins and naphthalenes. These are the 4 different kind of hydrocarbons composition that we have in the crude oil, and definitely their properties matter. Their density, viscosity, pour point, flash point, and so on. All those properties are matters, and we need to have all those properties because when we do the calculations, we need them, and so on. So mainly this is the aromatics one, which is the building block of hydrocarbon benzene ring, and then we have lots of non-hydrocarbon components, and also, for example, we have the oxygen. Okay, we have sometime when we produce the oil, so there's that oxygen with it. Sometime it has the sulfur, sometime it has the nitrogen, sometime it has the carbon dioxide. So carbon dioxide, sulfur, nitrogen, helium, sometimes the metal particles. So there's a lot of non-hydrocarbon and very hazardous, toxic, and dangerous gases can come out with the oil, and which we have to remove them at the surface. That's why we have to be very careful. Now, the other question comes, how the generation of petroleum happens. And for that, again, I will share one. I talked about it in the last lecture, but let me share one video before I go to this one.
Drives our cars, buses, and planes, powers our electricity, and allows us to cook our food and heat our water. Most of today's energy needs are met by fossil fuels like coal, oil, and gas. These unique, high-energy fuels are non-renewable resources that took millions of years to form. About 2 billion years ago, marine organisms like algae and microscopic animals and plants died and settled on the ocean floor. Beneath other sediments in the ocean, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. The whole process usually takes at least 1 million years. At the molecular level, oil and gas are hydrocarbons made up of hydrogen and carbon atoms. The constant pressure and movement of the Earth's crust squeezes oil and gas through the pores or spaces within rocks. Some oil and gas reaches the Earth's surface and seeps out naturally into land or water. Often it is trapped beneath the surface by impermeable layers or rock structures, like faults and folds. Within the crust, oil or gas deposits build up and form reservoirs. Reservoirs are like vast sponges filled with oil and gas. They can be as large as a city. To find oil and gas deposits, geologists use a number of different survey techniques, including seismic surveys, gravitational surveys, and geological mapping. Seismic surveys use reflected sound waves to produce a 3D view of the Earth's interior. New technologies, such as four-dimensional projections and sophisticated graphic renderings of rock structures, are improving the way we find conventional oil and gas deposits. Energy resources that are currently difficult or expensive to extract are called unconventional oil and gas. In a world with limited energy resources, people are looking at more efficient ways of tapping into unconventional oil and gas, or at alternative and renewable sources of energy from biofuels or the sun. What do you think will be?
Okay. Now, we will stop the lecture here, and we will continue in the next lecture. So far, any questions? Anything?
Sir, sorry. Oil is an organic or inorganic?
It's, I don't know whether it's an organic or inorganic. It's very, oil is an oil, crude oil we call it.
But actually, I read an article saying there is two theory. One is saying organic and the other is saying inorganic. And I wanted to make sure of which one is right.
Even I personally, nothing comes in my mind, whether it's an organic or inorganic. It's made of organic material called kerogen. That's what I know. But Indian, I call them the hydrocarbons, the carbon and hydrogen, so not organic. It's made of organic material, but Indian, it is no more organic. That's my answer, but I'm not sure about it.
Yeah, thanks so much.
Doctor, should you memorize all of the stuff that you have talked about, or you just should get to know them?
Well, in the lectures, whatever is there, you have to. Okay. Whatever in the formal slides is there, yes, you have to. You will see them in somewhere in test question somewhere. For example, what is petroleum engineers? Okay. What are the domains, disciplines of petroleum engineers? The reservoir, production, drilling, and so on. Okay. What are the 5 stages of oil industry, petroleum industry, which is the exploration, appraisal, and we talk a little bit about them. I don't mind in your own words. Actually, I would appreciate it if you write in your own words. Okay. How the oil is formed. Okay. It is formed through the dinosaurs many years ago. What is the kerogen? What is the migration? So these are the simple definitions that you will see. Yes. Okay. And same are given in the presentations. It's fine.
Yes, doctor. Thank you so much.
Okay. Any questions? Okay. Yes, I will put this video again back to the Google Classroom. Okay, along with this PowerPoint presentation and along with those videos, so you can review it at your time. And do let me know. And another thing I would like to inform you that we probably are going to have a workshop on Python. Python is a programming software that you may need it for during your master's degree. So we are going to do a workshop on it, probably on 30th of September. So join it, and I will be there also with you. Maybe it's going to be online because the guy is in US, the associate professor is in US, so maybe we do it online from home. I will update you regarding that. So any questions? Okay, so we end up the lecture here, and see you in the next class.
Thank you so much.
Have a
Thank
nice
you, sir.